Hello everyone and welcome to this video on Indices and Surds. In this video we will discuss some basic laws of indices, we'll understand what is surds and see how to rationalize those surds and how to find the square root of a surd. So let us begin. Before discussing the laws of indices, let us understand this small concept. If I add three numbers, let's say A plus A plus A, all these three numbers are equal, so I will write this addition as 3 times A. Now instead of adding these numbers, what will happen if I multiply these numbers? So it will be A into A into A, and this can be written as A cube. So this format of representation is known as indices, where A is called as the base and the number to which it has been raised is called as the power or the exponent. So any number which is of the form of a raised to n, where a is the base and n is the exponent, is called as indices. Now there are certain laws of indices which will help in solving the problem. Now one thing to note here is you don't have to memorize these formulas, you have to internalize these formulas so that while solving the problem it should come naturally. You should not feel like you are applying some formula. So let us discuss the laws one by one. The first law, let's say if there are two numbers a raised to m into a raised to n. So this product can be written as a raised to m plus n. That is, if the base of the two numbers are equal, then the powers can be added. The second law, a raised to m upon a raised to n. This can be written as a raised to m minus n. So again, if the bases are equal and the number is in division form, you can subtract the powers. Let's take the third law, a raised to m the whole raised to n. So this can be written as a raised to m into n. Consider one example, let's say 2 cube the whole square. So this can be written as 2 raised to 3 into 2, which is 2 raised to 6. Now one important point to note here is, in this case the entire thing is raised to the power n, whereas in other case, had this been written as 2 raised to 3 square. So you will have to evaluate the value of 3 square and then you will raise 2 to this value of 3 square. Whereas in this case, you can directly multiply the power because of this bracket, since this entire thing is raised to the power 2. Whereas in this case, only the number 3 is raised to the power 2. So we will first evaluate what is the value of 3 square. So as we know, 3 square is 9. So this will become 2 raised to 9. Whereas in this case, it came out to be 2 raised to 6. So please take care of this small difference between these two representations. Let us see the fourth law. A raised to minus n. So if the power is negative, so this can be written as 1 upon a raised to m. This negative sign indicates the inverse, as in if we write it as a raised to minus 1, we know it is 1 upon a. So a raised to minus m can be written as 1 upon a raised to m. Similarly, a raised to minus x by y, this can be written as 1 upon a raised to x by y. Let us see now our next law, nth root of a. This can be written as a raised to 1 by n. Let us take one example, cube root of 8. This can be written as 8 raised to 1 by 3. Or if you have the representation as 27 raised to 1 by 3, then this means we have to find the cube root of 27. So in this way you can use this representation. The sixth law, which is a into b the whole raised to m. If a number is represented in this format, you can split up the power. This can be written as a raised to m into b raised to m. Similarly, if there are two numbers which are of the form of a by b the whole raised to m, this can again be split up as a raised to m upon b raised to m. So as you can see, these are pretty basic rules which you don't really have to memorize them. You just need to get an understanding so that these rules comes out naturally while solving the problems. Let us now see the two important values that you need to remember while solving problems based on indices. Number one is any number raised to the power 0 will always be equal to 1. And the second rule, that 1 raised to any number will always be equal to 1. Let us now solve few problems and see how to apply these rules. Let us take this problem. We'll have to simplify this So the numbers given here are quite huge. 1331 upon 729, the whole raised to minus 2 by 3. Then 121 divided by 576 raised to half. And this thing is divided by 3 by 11 raised to 1. So let us see how to solve it. Now 1331 is nothing but 11 cube. And 729 is nothing but 9 cube. So the numbers in the questions of indices will be such that you can represent these numbers either as a square or a cube or to some higher power of a natural number. Similarly, this 121 is nothing but 11 square and 576 is 24 square, and 3 by 11 is already in the reduced form. So we'll substitute these values here. We'll get 11 by 9 the whole cube, and this entire thing has been raised to the power minus 2 by 3 multiplied by 11 by 24 the whole square, and this entire thing is been raised to the power 1 by 2. Now here we have a division. So what we will do is we'll write the reciprocal of this. So it will get converted into multiplication. It will be 11 by 3. Now note here, we have a cube here and we have to take the cube root as well. So this cube root and cube will cancel out. So what we will be left with is 11 by 9 the whole raised to minus 2. Since this is negative power, we will write this as 1 upon 11 by 9 the whole square. Now instead of writing it in this way, we can write it as 9 by 11 the whole square. This is one and the same thing. And this thing, now if you notice, we have a square here and we have to take the square root as well. So the square and the square root will cancel out. We'll be left with 11 by 24. And this thing will be multiplied with 11 by 3. Now if we simplify, so we have 11 square here. We have 2 11s, so this will also cancel out. We'll be left with 9 into 9 upon 3 into 24. So 3 ones are 3s are, again 1s are 8s are. So this will be 9 by 8. So in this way you can simplify numericals by using the principles of indices. As you can see, we don't really have to remember those rules. It came out naturally. So you just have to get an understanding of how to apply those rules and it will automatically come out while solving the problems. Let us take one more example. Now in this case, what we have to do is we are given two equations. This value is equal to this value and we have to solve for x. We need to find what is the value of x. So let us see how it is to be solved. As you can notice, this thing 3 by 4 is raised to the power x plus 2 divided by 4. That means we have to raise this number to the power x plus 2 and find its fourth root. So what we will do instead is we will raise both the side to the power 4. So this 4 and the power that we are going to raise will cancel out. So this will become 3 by 4 the whole raised to x plus 2, and this thing will become 27 by 64 the whole raised to 4. Now if you notice this number 27, it is nothing but 3 cube, and the number 64, it is 4 cube. Why we are using 3 cube and 4 cube? We could write this 64 as 2 raised to 6 as well, but since we have 4 here, we'll take the base as 4 and not as 2. This will help us in simplifying. So this equation can be written as 3 by 4 the whole raised to x plus 2, and this will become equal to 3 cube upon 4 cube, and this entire thing has been raised to the power 4, which can be written as 3 by 4 the whole cube and this entire thing raised to the power 4. Now this is of the form of a raised to m and the whole raised to n. So this can be written as 3 by 4 the whole raised to 3 into 4, which will give us 3 by 4 the whole raised to 12, and this thing is equal to the left hand side, which is 3 by 4 the whole raised to x plus 2. Now the bases are equal on both the side, so we can equate the power as well. So by equating the power, we'll get x plus 2 is equal to 12, so we'll get the value of x as 10. So by using the law of indices, you can solve for unknown values as well. Let us now understand the concept of surds. Now any number that can be expressed in the form of a by b, it is called as a rational number. Examples: 1.2, this can be expressed as 12 by 10, which can be further reduced down to 6 by 5. So this 1.2, it is a rational number. Then if we take 0.333, this can be expressed as 1 by 3, hence it is also a rational number. It is of the form of a by b. If we take another example, 1.333, this can be written as 4 by 3, hence it is also a rational number. Whereas the number that cannot be expressed in the form of a by b are called irrational numbers. For example, the value of pi, which is 3.14159 and so on, this value cannot be expressed in the form of a by b. It just goes on indefinitely and there is no fixed pattern. So this number is called as an irrational number. And if you find out the square root of these irrational numbers, these numbers are called as surds. For example, square root 2, square root 3, then square root 5. The value of these numbers cannot be expressed in the form of a by b. The value of square root 2 is 1.4142 and so on. It cannot be expressed in the form of a by b. Likewise, the value of square root 3, square root 5, these cannot be expressed in the form of a by b. So such values, square root of the numbers which cannot be expressed in the form of a by b, are called as surds. So we just keep it in this way only. Now among these surds, we are interested in the quadratic surds. So what are quadratic surds? Any number which is of the form of a plus square root b is called as a quadratic surd. Now there are certain limitations with respect to solving quadratic surds. For example, if we have the surd in the form of 1 upon a plus square root b, then it is not possible for us to apply any mathematical operation on this form. So what we'll have to do is we'll have to make the denominator into a rational number. We'll have to make it into a rational number. So the process by which we can make the denominator into a rational number is called as rationalization. So to carry out rationalization, we'll have to multiply this surd by its conjugate. So for any surd which is of the form of a plus square root b, its conjugate values will be given by a minus square root b or minus a minus square root b. So these are the conjugate values of a surd which is of the form of a plus square root b. In case of a surd which is of the form of a minus square root b, its conjugate value will be a plus square root b or minus a plus square root b. So for rationalizing a surd, we'll have to multiply the surd with its conjugate value. So if we multiply this surd with its conjugate value, what we'll get is a plus square root b. So this will be multiplied with a minus square root b. Since we are multiplying a minus square root b in the denominator, we'll have to multiply it in the numerator as well to balance it out. Now if you notice, this has become of the form of x plus y into x minus y. This can be written as x square minus y square. So the denominator will become 1 upon a square minus square root of b the whole square, which will become a square minus b, and the numerator will become a minus square root b. So once the denominator has been rationalized, you can perform any mathematical operation and solve problems based on surds. Let us take a few examples and understand how to solve problems on surds. Now this expression, which is written in the form of 3 upon 5 raised to 0.5, which is nothing but square root 5, plus 2 raised to 0.5, again it is square root 2, plus 1 upon 6 raised to 0.5, which is square root 6, plus 5 raised to 0.5, which is square root 5. And we have to simplify this. Now to simplify this, since the surd is given in the denominator, we cannot perform any mathematical operation. We'll have to first rationalize it. So we'll rationalize both these surds by multiplying them with their conjugate. So for the first case, it will be 3 upon square root 5 plus square root 2 into square root 5 minus square root 2. And in the numerator also we'll have to multiply it with the conjugate so as to balance it out. And for this case, we'll have square root 6 minus square root 5 in the numerator, and in the denominator we'll have square root 6 plus square root 5 multiplied with square root 6 minus square root 5. So this will become equal to 3 into square root 5 minus square root 2 upon x plus y into x minus y will be x square minus y square. So we will have 5 minus 2, which will be 3, plus we'll have square root 6 minus square root 5, and this will again become x square minus y square, which will be 6 minus 5, which will give us the value as 1. So now to simplify it further, we can cross multiply these things. So we will get 3 times square root 5 minus 3 times square root 2 plus 3 times square root 6 minus 3 times square root 5, and this whole thing will be divided by 3. Now this plus 3 root 5 minus 3 root 5 will cancel out. So we will be left with 3 root 2 plus 3 root 6 the whole divided by 3. So again this 3 will also cancel out. We will be left with square root 2 plus square root 6. So in this way you can simplify the surds by multiplying it with their conjugates. Now we cannot simplify it any further. Let us now see how to find the square root of a quadratic surd. Now if you notice, this number is given in the form of 18 plus square root 308. So basically this number is x plus square root y, and we have been asked to find what is the square root of this number. So we will have to take the square root of this number. Now how to find the square root of a number which is of the form of x plus square root y? So for that we'll assume the square root as root a plus root b, and then we'll square both the sides. So after squaring both the sides, this square and this square root will cancel out. We'll be left with x plus root y. This will be equal to, if we square this thing, it will be a square plus 2 times ab, which will be 2 times square root a into square root b, plus b square. So b square again, so the square root and square will cancel out. We'll be left with b. We'll club all the rational part together and we'll keep the irrational part separate. So we'll get a plus b plus 2 times square root ab, and on the left hand side we have x plus square root y. Now once we have reached this stage, what we will do is we'll simply compare the rational part and the irrational part. So if we compare the rational part, we'll get x is equal to a plus b, and we'll get y is equal to, if we take this 2 under the square root, we'll get square root of 4 times ab. So y will be equal to 4 times ab. So we have the values of x and y. We can solve for the value of a and b. Once we get the value of a and b, the square root of this term will be equal to, as we have assumed it to be, square root a plus square root b. So in this way you can find the square root of a surd. So let us understand with the help of this example. So we have to find the square root of 18 plus square root 308. So we'll assume this square root to be root a plus root b. Now we'll square both the sides. So the square and the square root will cancel out. We'll be left with 18 plus square root 308. And the square of this thing will be a square plus 2 times ab plus b square. So a square in this case will be square of this term, which will give us a, plus 2 times square root ab plus square of this term will be b. So now we'll separate the rational and irrational parts. We'll get a plus b, plus we'll take this 2 under the square root, we'll get 4 times ab. On the left hand side we have 18 plus square root 308. So now we'll compare the rational part and the irrational part, and from there we'll get the value of a and b. So we have a plus b is equal to 18 and 4 times ab is equal to 308. So from here we'll get ab is equal to 4 ones are 4 twos are 7s are. So a into b is 77 and a plus b is 18. That means there are two numbers such that their sum is equal to 18 and their product is 77. So how do we find that? We'll write down what are the factors of 77. So factors of 77 will be 1 into 77. Then the next factor will be 7 into 11. So if we take the sum of the terms, so this is your value of a, this is your value of b. So a plus b in this case will be 78. But we want a plus b as to be 18. So this is not a possible value. We'll take the next factor, which is 7 and 11. So if we add them, we'll get 18. So this is what we need. So the value of a will be equal to 7 and the value of b will be equal to 11. So once we have this value, the square root of this number, we have assumed it to be square root a plus square root b. So this will be equal to square root 7 plus square root 11. So in this way you can find the square root of a quadratic surd. Let us now see how to compare two different surds. Now in this problem we have been asked to find which of the value is bigger. So whether this value is bigger or this value is bigger. So if you notice, these are nothing but square root 5 plus square root 23, and this number is square root 3 plus square root 26. Now you cannot use the approximation technique to compare these two values. Let's say if we were to use the approximation technique, now we know approximate value of square root 5 will be 2 point something plus approximate value of 23 will be 4 point something. So the approximate value of this surd will come out to be 6 point something. Now if we take the square root of these two values, square root of 3 will be approximately 1 point something. Square root of 26 will be approximately 5 point something. So if you add them, it will again come out to be 6 point something. So we cannot use the approximation technique for comparing these two values. We'll have to use another technique. So what we will do in this case is, we will square both these numbers. So we'll find the square of this number and square of this number, and then we'll compare them. So let's see how it is to be done. So if we square this number, it will be a plus b the whole square, which will give us 5 plus 23 plus 2 times square root of 5 into 23, which will be 115. So this is the square of the first term. What will be the square of this term? It will be again a plus b the whole square, which will give us 3 plus 26 plus 2 times square root of 3 into 26, which will come out to be 78. Now this will become 28 plus 2 times square root of 115. Now square root of 115 will lie between 10 and 11, because 10 square is 100 and 11 square is 121. So square root of 115 will lie between 10 and 11. Likewise, this will become 29 plus 2 times square root of 78. Now square root of 78 will lie between 8 and 9, because 8 square is 64 and 9 square is 81. Now by using these two values, we'll get a range for the first surd. So this will be 28 plus, if we take the lower value, it will be 2 into 10, which will be 20. And if we take the higher value, it will be 2 into 11, which will be 22. So the value of the first surd will be anything between 48 to 28 plus 22, which will be 50. Similarly, the value of the second surd will be 29 plus 2 into 16, or 29 plus 2 into 9, which is 18. So the value of the second surd will lie between 29 plus 16, which is 45, and 29 plus 18, which is 47. So the value of the second surd will lie between 45 to 47, and the value of the first surd is lying between 48 and 50. Now since the lowest value of the first surd is bigger than the biggest value of the second surd, we can say that the first surd is bigger than the second surd. Hence we can conclude that this number 5 raised to 0.5 plus 23 raised to 0.5 is bigger than 3 raised to 0.5 plus 26 raised to 0.5. So in this way we can solve problems based on surds and indices. In the next video we will solve some more problems based on surds and indices. Thank you.